With the aim of studying how multimodal AI is affected by sensitive information and training bias, we present a new testbed inspiring automated recruitment, FairCVtest. Suppose an algorithm that takes as input a resume and outputs a recruitment score. The CV includes both structured data, such as education, and unstructured data, such as a face photo or a short bio, which are sources of sensitive information that can originate certain biases, for example, gender and ethnicity. We have generated a new dataset with 24,000 synthetic profiles, FairCVdb. Each profile includes 12 features obtained from 5 information blocks: education, availability, previous experience, language proficiency, and recommendation letter, 2 demographic attributes, gender and ethnicity, a face image from the face database, and a candidate score. We use a linear combination of the merits to assign a score to each profile, using weighting factors generated by human resource expert and adding a small Gaussian noise to introduce a small degree of variability. These scores are used to rank the candidates in a simulated recruitment process. Additionally, we introduce gender and ethnicity biases as penalty factors for individuals belonging to certain demographic groups. We designed a multimodal learning framework including a ResNet 50 architecture and a feed-forward network with 2 hidden layers with 10 units and 1 output neuron. The aim of the model is to predict the candidate score using the features available in the profile. We have evaluated different scenarios based on the scores with and without bias and the input features. In scenario 3, we use the gender bias scored as target function and only the merits as input features. In the table, we show the distribution by gender of the top-ranked 100 candidates. Even in the presence of the bias score, the unavailability of the demographic information for training the network results in a fair representation of candidates from both genders. If we now add the demographic attributes as input, then the learning process is able to establish a correlation between the gender attribute and the bias introduced in the candidate score. Thus, we obtain a recruitment tool with a strong bias reproducing the bias introduced in the score. We now replace the demographic attributes by the face image, once again with the bias score as target function. Despite not having explicit access to sensitive information, the model is able to extract this latent information from the face image. Therefore, we obtain another biased model. Finally, with the aim of preventing the learning process to exploit sensitive information, we apply a method capable of removing sensitive information from the feature embeddings, sensitive nets. Using the new agnostic feature embeddings, the system can extract the gender attribute, and therefore the trained model cannot reproduce the data bias anymore. Our testbed FairCVtest is available in GitHub, and a related video demo can be found in YouTube. Search for FairCV demo. Thanks for your attention.